Okay, so our first warm-up for this one for multiplying and dividing, this is just like a recap of simplifying. So we have one x that's left on top when we cancel out those two x's. I like to think about like questions like the second one, kind of like almost like balancing when I think about all the x's. But let's talk about the coefficients before we do the x's. So what did you guys do with like all of these to simplify them? Alan, what did you do? Okay. Yeah, perfect. So I might just focus on just the numbers for a second. I'm going to take out a 2 from 4 and 2, so I'll be left with 2 and 1. And then from 12 and 3, I'm going to take out a 3, so I'll be left with 1 and 4. And then I just want to think about, like, I always think about these ones kind of like balancing. So how many total x's do we have on the top? Charlotte? We have 3 here, and then we also have...
Oh, like without reducing it? Oh, then there's 5.
Okay, so there's 5 on top. How many total are on the bottom before we've canceled? 2. So if I have 5 x's on top and 2 on the bottom, I'm going to cancel out, I can only cancel out a maximum of 2 from each, right? So if I cancel out 2 from each, I'm left with 3 x's on top, right? That's kind of how I like to think about these. So I'm literally, or we could even see I have an x squared here, and I have an x and an x, and those will basically cancel each other, right? So we'll be left with 3 on the top. So we're going to have 2 times 4, which will give us 8. We have an x cubed left, and then really all that's left on the bottom is 1. So we don't have to write over 1. Jack?
I think it's completely different, but I got the same answer.
Yeah, that's fine.
Okay.
Did you multiply everything first?
No, I simplified the x's from each side, so I ended up with 4x over 3 times 6x squared.
Mm-hmm.
And then I did like 4x over 3 times 18 or 18x squared over 3, and I got 72x cubed over 9.
Mm-hmm. And then you have to reduce the 72 and 9. Yep. Sometimes it's like a little bit easier to do like cross-reducing first. But yeah, if you did it in a different route and you still got the same answer, it should be fine. Okay, so I want to recap some restriction stuff, but I'm actually going to change these because we did these in an earlier lesson, so I'm gonna switch those in a second. But restrictions from here on out, we're going to make sure that we have these for like every single question that we do that has variables in the denominator. So restrictions, just as a recap, we need to make sure any variable that's in the denominator never equals 0. So anytime I have variables in the denominator, I should always have expressions like x cannot equal this to indicate what I don't want to sub in for x that would make that denominator 0. So let's suppose we have the equation x plus 2 over 2x plus 1. Firstly, how do I solve something like this for where this would equal 0? Like I have to restrict this x so that I don't end up getting 0 on the bottom. How do we find that for something like 2x plus 1? Jack?
You sub in x is 0.
So if I sub in x as 0, I just get 2 times 0 plus 1, and that's going to give me 1. So that shouldn't be a restriction, right? So we could, if we're unsure of what makes this 0, we could make this equal to 0, and then just kind of like solve for where this cannot equal 0, right? So I would move the 1 over, and then I would divide out that 2 there, and I'd get that x cannot equal negative 1 over 2. So that's the restriction. Do I have to also say that x cannot equal negative 2? Why not, Ryan? So if I plugged in -2, the top would end up being 0, but the bottom doesn't, so that's okay.
So it's just the bottom right hand here.
Just the bottom, yeah. Okay, this one we actually we won't do that. So that's our recap. This equivalent functions and expressions thing that we learned from our first lesson is also important. How do I test, once I've simplified something, if it's equivalent to what I started with? And that's actually how I can check all of my answers for this unit. So let's look at like this example, for instance. How could I check that what I started with here is equivalent to this? Alan, what would you do? Okay, so let's try it down here. We started with, I might actually have to erase some of this so I can see what we started with. We started with 4x squared times 12x cubed over 3x and 2x. And we said that ended up simplifying to 8x cubed. So I want to test whether this is equal to this. Keith, choose an x value for us. Choose an x value. Yep. Not 1. Anything but 1. Not 0 either. Sorry, anything but 0 or 1. Okay, that works. Okay, the reason why I'm saying don't choose 0 for these ones in particular is that if we choose 0, just everything becomes 0. And then if we choose 1, everything to the, like, if I raise 1 to a variety of exponents, I'm just going to get back 1. So that's not necessarily like a great check for us to do. So we could choose something like, let's choose x equals 5. So I want to test if I plug in 5 into the original. If that's going to equal x as 5 in the final. So we're going to actually plug this into our calculator and double check the values here. So everybody grab your calculators. I'm going to do it too. And if you want to take this like piece by piece, you can do that, or you can try to plug it all in at once. Okay, this is 100 over 15 times 1500 over 10. So I got 10,000 for this one. 5 cubed, 125, I think. So 8 times 125, I think that gives us what we need. Okay, and I get 10,000 for this. So is what I started with equal to what I finished with here? So yes. So therefore, they are equivalent. So when I go to do like an assignment or a test for this unit, I should be able to know whether all of my answers are correct or not, right? In the end, because I can just sub in a value into my variable and I can double check that what I started with is the same as what I finished with. The only thing this doesn't tell me is if I've simplified the expression enough. So if I had left, let's say maybe I left like an x and I had 8x to the 4 over x, and then I didn't simplify these, I'm still going to get 10,000, but I know that, like, if I look at that, I know I can simplify those x's further. So you have to kind of use your common sense as well to determine whether these are going to be equivalent or not, and whether you've simplified enough. Okay? So this is a check. I would encourage you guys, as you're doing your homework, especially with those exponent type questions like the one that we did on the board, make sure you know how to use your own calculator and plug this into your own calculator. That will be important. Okay? All right. So we're going to simplify and state restrictions. What is one thing that I'm not going to do to start this? What is the math crime that I'm going to tell you guys about right now, or remind you guys about? What's the math crime? No one knows what the math crime is? Maybe if I do it, you can tell me what the crime is. So sometimes I have students that go and they start by doing this. I'll reduce this by 3, this by 3. Is this okay? Why is this a math crime? How do I know that this is a math crime? What's the issue here? Come on, guys. I know some of you know. Try to participate, okay? Okay, Liam. It's next to an addition or a subtraction sign. So I can't selectively cancel out individual terms like this. Okay, so what's the correct way to start something like this then? We worked on this in our first lesson. I need to get these in like bracketed form, so how do I do that? Alan. Factor. Okay. How do I factor x squared minus 9 then? This is a special thing. Raul? And? Okay. X minus 3, x plus 3, this is difference of squares, right? Bottom, I want to find two things that multiply to 12 and add to 7. Alan? 3 and 4 should work. So easy factoring, x plus 3, x plus 4, right into the brackets once we have the numbers. Okay, before I start canceling, I want to write restrictions. X cannot equal. Who can tell me the restrictions? Jack? It is negative 3, negative 4. So that comes from these two brackets on the bottom. Okay, so now that I have multiplication happening in between my brackets, I can cancel any common full brackets out that are the same from the top and bottom. Helen? Yeah. Okay, we did a little bit of practice with this on our first worksheet, so. This is part of my answer, and this is my final simplified answer here. Again, how can I test that this is the same as this? Okay, so I will choose x equals 2 or something like that. I'm going to plug it in here, and I'm going to plug it in here, and I make sure they give me out the same thing, right? Okay. Guys, can I please ask you that phones go like stored away in backpacks, please, for lessons? Okay, this is like one thing that I haven't been as strict during work time, but during lesson time, you need to have it stored away. Like I don't want to see it out on your desk. Okay, you're supposed to be focusing in here. Okay, what do these restrictions look like on a graph? That would be an interesting thing to kind of see and actually visually like take a look at. Jack? Okay, so one of them here is going to produce a hollow point. Let's look at Desmos for a second. So I'm going to graph the original function because that one contains all the restrictions in there. So we'll have x squared minus 9 over x squared plus 7x plus 12. And it did not, probably because of this. There we go. All right, so we had restrictions at negative 4 and negative 3. What is happening at negative 4? Negative 4 is right here. Jack? So what did we call those? It's kind of like that vertical line that our graph curves around. It's an imaginary line. Charlotte? An asymptote. But there's no asymptote at -3. You guys see this? Right at -3 here? The graph crosses at that point. So that's what Jack was talking about, which is if I slide along, actually let's put this in projector mode. If I slide along where -3 is, we can actually see that I have like a little hollow undefined point at -3. So why did one of these restrictions produce a vertical asymptote, and then why did the other one produce a hollow undefined point like that? What's the difference between the two restrictions? What happened in our process here? Charlotte? So the one that had that hollow point that's appearing on our graph ends up getting canceled out along the way. So the only restriction, like if I didn't see anything else here, the only restriction that I would actually notice from the final answer would be -4. That's the vertical asymptote. The one that gets canceled out along the way does not produce a vertical asymptote. It produces a hollow undefined point. So that's the difference between when we get vertical asymptotes and when we get those hollow points. So let's just draw ourselves a little picture here of what we had. So at -4, we had a vertical asymptote. So our graph kind of like curved around both of these, like so. Okay, and then at -3, we have a hollow undefined point. Okay, so that's our main difference. I'm going to look, when I'm determining whether a restriction is like a vertical asymptote or an undefined point, I'm going to look at my math work, and I'm going to say, can I see that final restriction that I had in my final answer? Keith? In the backpack, okay? Store it away. I'll wait. Okay, so I'm going to see, is it visible in my final answer where it came from? If yes, that's a vertical asymptote. If it got canceled out along the way, that's going to produce one of those hollow undefined points that we talked about, like back from Unit 1. Okay, so as we go along in our lessons, I'm just going to kind of ask you guys those questions as we finish up, just so that you guys can kind of get the hang of like which ones are making vertical asymptotes, which ones are making those hollow points. All right, so we've got a couple steps. I'm going to focus in the first half of class here, or the first part, on multiplying, and then we'll do, when we come back from break, we'll do dividing. So the very first step for any of these types of questions is we always want to fully factor and common factor everything we possibly can. So all numerators, all denominators, factor, common factor. Second thing is, before I start canceling anything, I'm going to write restrictions, just so that I don't miss any of them. Because if I wrote restrictions at the end here, I might have missed this restriction of -3. So write your restrictions before you cancel. And then you can cancel any top with any bottom as long as it's like a full group in brackets. As long as there's multiplication, no individual pieces. If I go to cancel something right next to an addition or a subtraction, I don't do that, right? I always have to stop myself. So let's try a couple. So first step, always factor and common factor everything you possibly can. So these ones, I don't think we can really factor these. There's no trinomials like x squared, x, and constant type terms. There's no difference of squares like x squared minus something. So probably the most that we can do is if I have multiple, like if I have additions or subtractions, is just see if I can common factor. So is there a common factor here? There's something higher than 2, 4. Okay, so your common factor doesn't disappear. It has to go out front of a bracket. I'll be left with x plus 6 here. How about this guy? Any common factors here? X. So take out an x. We'll be left with x plus 8. Not much I can do with 12x squared. I can't really common factor a single term, so that will stay as is for now. Okay, and then how about bottom right? Any common factors here, Jack?
3 and it's 3 times x plus 8.
Good. Okay, so we did the first step. We factored and common factored everything. I'm going to start a list of restrictions now. X cannot equal. What will I put? I want to make sure any variable that's in the denominator gets a restriction. Charlotte? Okay, that's 2 of them. I need 1 for this as well. What would I do for like a single x like that, Alan? 0. Because if I plugged in 0 for x, I would have 0 times 0 plus 8, and that will make the whole thing 0. So if you ever see like an x that's not being added or subtracted with something, that one will give you a restriction of 0. Okay, now that we have that, now we can start canceling things. So because I have multiplication in between, I can cancel up and down, but I can also cross cancel as well. That's only when I have multiplication in between. So what things do you guys see can be reduced or canceled? Charlotte? Okay, so we'll do the x plus 6s. Those will cancel. What else? There's more. Alan? Perfect. So I'm going to cancel out an x from here and an x from here. So I'll be left with, I'll just cancel out the squared there. I'll be left with a single x. There's one more thing. It can be diagonal or it can be up and down. 12 and 3. So we're going to reduce that to 1 and 4. So what's left? Well, I have 4 times 4x. That will give me 16x. And then really all that's left on the bottom will be an x plus 8. Is there anything else that we missed that can be canceled here? What about the x's? Can I cancel these? What's the rule with canceling? Jack? So this is next to a plus, so I don't want to cancel those, right? What about the 8 and 16? Should I reduce to 2 and 1? Also can't do it. 8's right next to a plus. So are we finished then? Okay, we're good. So these are our restrictions. This is the final simplified answer. Can somebody tell me which of these restrictions are vertical asymptotes and which of them would be undefined points? Jack?
-6 is undefined because that was what was canceled out.
Mm-hmm.
-8 is the asymptote.
What about 0?
Is 0 also an asymptote? Or I know like if it's so considered like but it's in the middle, so it would be.
What do you think, Charlotte? 0, this one does get canceled out, so these are both undefined points. Maybe I'll just write it out for now. So, okay, perfect. We know 8 is the asymptote because the x plus 8 is left here, so we know -8 must be the vertical asymptote. Jack?
Would be like one asymptote?
No, not necessarily. There could be multiples. That's a good question. Okay, we're going to save the division 1 for the second part of class. Any questions on this before we go forward? Okay, let's go to B. And then we'll do C and D afterwards. All right, so step 1, factor and common factor everything you possibly can. The first step of any trinomial factoring as well is always common factor first. So I would look through everything here and see if there's any common factors for anything. So do we have any common factors anywhere that we need to take out from anything? I don't think so. So then we move on to factoring. So this is why I told you guys that we need to make sure we know how to do factoring, because we're going to do it a bunch of times in this unit, and we're going to be doing it for multiple pieces of these questions. So I need to factor, if I can, both this and this. This is going to be hard trinomial factoring. So I'm going to do a recap with one of these, and then I'm going to just be factoring these quickly after this in this unit. So you need to be able to factor these yourself, right? So I'll do a quick recap. We need to do, when we have a value in front of x squared like this, we need to do a times c. So I'm looking for two numbers that multiply to 40, and they need to add to the middle value, which in this case is negative 13. So what are the numbers? Jack, you got them? Okay, negative 5 and negative 8 should work for this. So we're going to split the 13 up into negative 5x and negative 8x. I did post a video as well on how there's other methods that you can use for factoring stuff like this. So choose a method that you feel works for you and practice that for these hard trinomial questions, okay? I'm going to show you the most common method, which is just this grouping method that we've been working on. Okay, common factor something from each group. I'm going to common factor a 5x from the first group. I'll be left with x minus 1. And I'm going to common factor a negative 8 from the second group. I'll be left with x minus 1. And I know that this is on the right track because my brackets are the same. So the final factored form here, I'm just going to write this right in the question, will be x minus 1 times 5x minus 8. Okay, I also reviewed with you guys another option, which I'll just show you briefly here for factoring. So we'll talk about this one, which was this x method, like this. You guys remember this vaguely from the first lesson? So we look for two things that multiply to a times c still, so that will be 10 times negative 8, so negative 80. And we look for two numbers that add to negative 11. So either way, you're finding the two numbers for these two methods. So adds to negative 11, multiplies to negative 80. Alan, you have the numbers? Negative 16 and positive 5 work. And then what we would do is we would take this a value and put these over the a value and reduce. So I get 1 over 2. And I'll reduce both of these by 2, so I'll get negative 8 over 5. And those actually will give me my brackets. They're kind of buried in there a little bit. They're going to give me the bracket of 2x plus 1 and the bracket of 5x minus 8. So you choose a method that works for you. There's also a little method that's like a crisscross method. I usually use that other method, but it takes a little bit of time to kind of get used to that method. So you choose something that works for you. Practice it moving forward. Yeah, and I'm actually just going to group this up so that we remember that I can only cancel out of that group unless I have another x minus 7 up there. So restrictions for this before we start canceling. X cannot equal. Okay. 7 is one of them. Others? Charlotte? Not 8. So we have to account for this. So not 1. Alan? 8 over 5. So I usually just like to flip the sign and then put it over this. That's the quick way to do it. If you're not sure, set 5x minus 8 equal to 0 and just solve for the x that makes that happen, okay? But quick method is switch the sign here. That'll go on top. This one will go on the bottom. So 8 over 5. How can we use that on this one? What's the last one? Negative 1 over 2. So switch the sign and then right over left. Perfect. So those are the restrictions. Can we cancel now? Is there anything that can be canceled or reduced? We will cancel the 5x minus 8s. Good. And we should be left with, we have x minus 1 times 1. That's just x minus 1. And then we'll have x minus 7 and 2x plus 1. Factored form is simplest form. So don't go in FOIL after this. We don't need to now expand this out. Factored form is the best, most simple form. Okay, so you can maybe just make yourself a note here. Factored form is simplest form. So if something asks you to simplify and state restrictions, you're always going to make sure that your final answer is in factored form. Okay, so we're going to do some practice on this before we go on break and then a little bit after the break as well. So the first section of your worksheet, let's pause. So let's take a look at the division questions. So the division questions are going to be very similar to the multiplication questions because when we divide fractions, we eventually will flip and multiply, right? So these are the steps for division. We will factor and common factor any numerators and denominators as usual. Restrict as usual, so same steps as the multiplication stuff. Then we will flip the second fraction and change that division to multiplication, so flip and multiply. Restrict any new things that are in the denominator, and then you can start to cancel stuff, okay? So just a couple extra little things for division type questions. So we're gonna start out by factoring and common factoring everything we can here. I don't think that there's much that we can do with x plus 1, so we'll leave that. 2x is just a single term, so we'll also leave that. Same with 3x, there's not much we can do with that. We can factor something like this though. This is trinomial factoring. So we want two things that multiply to 3 and add to 4. Charlotte? 3 and 1 should work. So because this is easy factoring, we're going to put these right into the brackets. So don't make it more complex than it needs to be. Just x plus 3, x plus 1. And I'm also just going to bracket this up just so that we remember that I can't cancel pieces of that unless I'm canceling with like another full x plus 1. So initial restrictions, let's start a list. X cannot equal. What do we get from both of these denominators for what x cannot equal? Jack? 0. Why did you choose 0 and not like negative 2 and negative 3?
Because when there's like, is it, when there's like a number of x,
Coefficient, yeah.
when it's multiplied, you can't put 0, else it's given 0.
Yeah, so if we put in 0 for either of these, I'll get 2 times 0, which makes the whole thing 0. Or I'll get 3 times 0, which will make that whole thing 0 as well. So x cannot equal 0. That takes care of both of those. Then we'll flip and multiply. So that's fraction rules. Take the second fraction, flip it, and when we do that, we can change the division to multiplication. Now before we cancel, I'm going to add to my restrictions list here. What extra restrictions do I now need to add to my restrictions list that are in the denominator now? Alan? Okay, so we need to add restrictions for both of these, negative 3 and negative 1. And then we can start to cancel things. So who sees some things that we can cancel here? Give me one. Keith? X plus 1s. What else? Do an x from here and here. I'm only allowed to do this cross-canceling because there's a multiplication in between here, right? I wouldn't want to do that at the point where I have division in between, or addition or subtraction once we get into that. Is there anything else that can be canceled? I don't think so. So we're left with a 3 on top and then a 2x plus 3 on the bottom. These are also part of our answer, so I'm going to box those. Okay, so some of you guys saw this in your worksheet. We want to keep things in like factored form, so I'm not going to bring this 2 inside the brackets or anything like that. Factored form will be your simplest form, so leave it out. And leave those brackets around the x plus 3 as well, because the 2 technically is multiplied by that whole thing. Okay, so very similar to multiplication, just a couple extra little things that we have to account for when we do division. Okay, let's do one more. So factor and common factor everything you possibly can. So I can only really do trinomial factoring if I have like something that's in this format, or if I have something that's in the difference of squares format, which would be like an x squared minus some kind of constant, which we don't really have. We have like an x squared with a minus, but it's not a constant that's being subtracted. So with this top one, how do we factor something like this? Or how do we like get it into more like bracketed form? Alan? Okay, so just common factoring then is all that we can do with that. He's right. So we'll take out a 2x. We'll be left with x minus 4. And then I want to factor both of the denominators here. So these are both easy factoring. We need to find something that multiplies to negative 10 and adds to negative 3. And then for this side, we'll try to find something that multiplies to 20 and adds to negative 9. Jack?
The first one can be negative 5 and 2.
Negative 5 and 2 works. Again, easy factoring, so numbers go right into the brackets with your x's. No sense.
And the other one is negative 4 and negative 5.
Perfect. So again, easy factoring. X squared has a coefficient of 1. So x minus 4, x minus 5. Okay, before we start canceling things, I'm going to start a list of restrictions. So x cannot equal. Give me a couple of restrictions. Charlotte? 5, negative 2, and one more. Jack? 4. So each thing here, I want to make sure I restrict. So 5, negative 2, and 4. And then we already have 5 for that second bracket there. Okay, flip and multiply. So first fraction stays the same, but we want to flip the second fraction. And we'll change the division to multiplication. Before we cancel, is there anything, now that we've done this, that needs to be added to the restrictions list? So we do need to restrict this. So what would make 4 times something squared 0? Charlotte? 0 needs to be added to the list, because if I plug in 0 here, I'll get 0 squared, and then I'll multiply that by 4, and the whole thing will become 0. Okay, now we can start to cancel all of these things. So what do you guys see that can be canceled out? Charlotte? X minus 5s can be canceled. Okay, perfect. What else? Patty? With this one? So this? You guys agree? Jack, why are you shaking your head no? Has to be a top with a bottom, right? So these ones are on the same level, so no canceling. But I'm glad you brought that up because that's a good point. Keith? Okay, so we'll take out a 2 from the 4 and the 2. We'll get 1 and 2, and then we'll also take out an x from each of these x's here. So that will be, there will be no x's left here and just 1 left here. So I'm just going to cross out that squared. All right, so we are left with really just x minus 4 times x minus 4. How could I condense that to be simpler? Charlotte? Okay, so we're left with x minus 4 squared. And then I'm left with a 2x, which normally we would write that out front, and then an x plus 2 in brackets. Okay, whenever I have like a coefficient and like a single variable or like a variable with some exponent, we'll typically write that in front of any other like brackets and stuff like that. So just as far as like proper mathematical notation. Okay, so that's our final answer. Nothing more can be simplified, and then the restrictions are part of the answer as well. Okay, for a question like this that has like so many restrictions, I would probably make the restrictions worth like a mark or so to make sure like that we hit every single one of those. Which one of these restrictions is what? Charlotte? 5 is an undefined point, correct?
The -2 an asymptote.
Yep. So this one's a little tricky because it has to be in the denominator of the final answer. I know that that one gets flipped up to the numerator, but it would have to be visible in the denominator. So does that change your answer?
Yeah,
Okay, so that would be undefined point. And what about 0?
the 0 is still vertical.
Yes, so that would be vertical asymptote. So basically the general rule is if you can still see what produced that restriction in the denominator of the final answer, that will be a vertical asymptote. So we can see 0 is produced by this, 2 times x, and then -2 is produced by this, but we don't see any of the other ones in the final denominator, so the other ones will be undefined points. So if you see what could cause the restriction in the final denominator, vertical asymptote. If you don't see it, if it got canceled out along the way, or maybe flipped up to the top, like this one got flipped up to the top, that's an undefined point. Okay, maybe we can talk about this one as well. Keith, did you have a question? Okay, so who can tell me what each of these are in part B? Vertical asymptote or undefined point? Keith? Okay, that's a vertical asymptote. Yep. What about -1/2? Because it comes from this. Okay, so these ones, -7, we can see in the final answer. -1/2, we can see that in the final answer, but this one gets canceled out along the way, so that's the undefined point. The other ones are vertical asymptotes. Yeah. Okay, that might be a good thing to just like do as you go along in your homework as well, just to kind of make note of it so that you can practice it. Okay, so we've got a half an hour, guys. We're going to also do the division section of this worksheet. So if you're not done the multiplication section yet, keep going with the multiplication, and then we're going to do division. Anything that you don't finish will be homework, and then we also have a quiz for next class. So you might want to go back and review if you have extra time today. Make some like summary notes and stuff like that so that you're ready for your quiz next week.